Chalo. Now coming to the periodic and aperiodic signals. In continuous time domain, periodic signals are defined as like this. If x of t plus capital T, where capital T is time period, is equals to x of t for all time t, that is for infinity to plus infinity, right? Even if it is from 0 to infinity, if the signal satisfies this condition, we cannot say it as periodic. It should satisfy this condition, that is x of t plus capital T equals to x of t for all time t. Remember that. Okay. So then what will be the frequency of that periodic signal? F equals to 1 divided by time period t, and frequency in radian per second is omega equals to, that is angular frequency, 2 pi f, which is also nothing but 2 pi by t, and t is fundamental period. Okay. Similarly, in case of discrete time, periodic is defined like this: x of n plus capital N equals to x of small n for all integers n. So here angular frequency omega is 2 pi by capital N, right? And capital N is equal to 2 pi by omega. Okay. And here similar to continuous time, capital N is fundamental period, right? We are going to discuss about some of the important points about periodic and aperiodic signals. So from these note points, first one is the sum of two continuous time periodic signals x1 of t and x2 of t with periods t1 and t2 may or may not be periodic depending on the relation between t1 and t2. Okay, like for the sum of two periodic signals to be periodic will be decided by the relationship between t1 and t2. Okay, but how? We will see. So the sum of two periodic signals is periodic only if the ratio of their respective periods, that is t1 by t2, is a rational number or ratio of two integers. So are you getting? So the ratio of those two periodic signals should be a rational number or it should be a ratio of two integers. Okay. Then the fundamental period is nothing but least common multiple of t1 and t2. So okay, if you have two signals which are periodic with periods t1 comma t2, and let us say the sum of those signals is also periodic, then what will be the fundamental period of that sum of the signals? Okay, t1 is for x1, t2 is for x2, then what will be the period of x1 plus x2? Is it going to be t1 plus t2? No, that is least common multiple, that is LCM of t1 comma t2. First to verify whether the sum is periodic or not, then you need to go for fundamental period, right? Because there can be a case where it may not be periodic. Suppose if t1 by t2 is not a rational number. Okay, right. Suppose if the ratio t1 by t2 is an irrational number, then the signals x1 of t and x2 of t don't have a common period, right? That's why x of t cannot be periodic. Okay, then the sum of two discrete time periodic sequences is always periodic. Wow, this is very nice, right? The sum of two discrete time periodic sequences is always periodic, whereas it is not if those two periodic signals are of continuous time. Okay, right. Thank you.